Hello class, today we're going to go over the Unit 1 review. So we'll start at the beginning here. It says use f of x equals 5x minus 7 to answer the following. A, what is the value of f of negative 9? Right, so to find f of negative 9, we simply just plug negative 9 in for x. So we have 5 times negative 9 minus 7 all over 8. Right, so 5 times negative 9 is negative 45, minus 7 is negative 52 over 8. That reduces. 4 goes into both of those evenly, so this reduces to negative 13 over 2. Right, letter B, when does f of x equal 0? All right, remember, this is very different than f of 0. What we're trying to do here is find an x value that makes this thing 0. When two things are equal, they are interchangeable. So if I have f of x equals 5x minus 7 over 8, I can replace f of x with 0. So I get 0 is equal to 5x minus 7 over 8. Right, the first thing I want to do is multiply both sides by 8. Of course, 8 times 0 is still 0. So 0 is equal to 5x minus 7. Right, well, then I add 7 to both sides, divide by 5. So x is equal to 7/5. Pretty straightforward there. All right, our next problem, the graph of a function is given. Use the graph to find the following. All right, so first we talk about domain. Right, the domain, of course, is all of the x values that this graph covers. So from left to right, the furthest left this thing goes is negative 6. Of course, we don't include negative 6 because it's an open circle. The furthest right this thing goes is 5. We do include 5 because it's a closed circle. And there's no breaks or anything in between. It's nice and continuous. So we include everything in there. So we say negative 6 to 5, including 5. All right, the range is all of our y values, so up and down. Of course, whenever we write things in interval notation, right, we want to go from the lowest number to the highest number, so we actually want to go from bottom to top here. Right, the lowest number that this graph touches is negative 4, and we do include negative 4 because of the closed circle, of course. Right, the highest this graph goes is positive 5. We do not include positive 5 because it's an open circle. So there is our range. The intervals on which f is increasing, so where is this graph going up? Remember when we talk about intervals of increasing and decreasing, they're always open intervals, so we always use parentheses. And remember, we only care about the x-coordinates, from what x to what x. Right, so increasing means that we're going up as we go from left to right. So we start going up from here. We continue to go up until we go here. So my x values, this is from negative 3 to 2. So we're increasing from negative 3 to 2. Right, the intervals on which f is decreasing. Right, decreasing, of course, means we're going down as we go from left to right. And we only care about the x values again. So here from negative 6 all the way to here at negative 3, we are decreasing. So negative 6 to negative 3. Right, and then we are also decreasing again from here, which is 2, down to here, which is 5. Remember, x values only. So 2 to 5. If you try to put ordered pairs from this x comma y to this x comma y, you will get it wrong. Be very careful. Intervals of increasing, decreasing, and constant are only x values. Moving on to number 4. It says to graph each function. Right, and we have some piecewise functions here. All right, so remember, first thing we want to do is kind of break up our graph so that we know we look at our conditions here, right? And it's obviously broken up at -1. So I'm going to put a vertical line, dotted line here at -1. All right, I'll do this first piece here in pencil. All right, so first thing we want to do is plug my condition in. So when I plug -1 in for x, we get -3 minus 2 is -5. So we have the point -1, -5. That will be an open circle because this is just a less than. So -1, -5, that open circle right there. Right now we can pick, this is true for any x is less than -1, so we can pick another x value less than -1. I'll just pick -2 because it's easy. If we plug -2 in here, we get -6 minus 2 is -8. So -2, -8. Right, 2 points are sufficient for a line. The straight edge will always help you. Right, so there is my first point. All right, I'll do my second piece here in red. We do the same thing. We plug -1 in here. So when I plug -1 in here, I get 2 minus 1, which is 1. So -1, 1. That is a closed circle because this is or equal to. So there's my closed circle on -1, 1. I can pick any value, any x value I want greater than -1. 0 is a nice, easy one to pick. If I do that here, plug in 0, we get -1. We have 2 points. That is sufficient for a line. And there we go. And that's it. We are done. All right. Next, over here, right, our area that our graph is going to be broken up. Our conditions here are at x equals 3. Right, so again, we can draw a vertical line, a dash line on x equals 3, just to let us know where this graph is going to be broken up. All right, I will do the first part in pencil. All right, so again, I take my condition of 3, I plug it in here. 3 minus 1 is 2, so I have the point 3, 2. That is an open circle because we're just less than. I pick a value less than 3. I'll pick 0 because it's nice and easy. Plug 0 in there, I get -1. So that gives me the point 0, -1. All right, and I can go ahead and make my line here again. There we go. All right, next one, I'll make this in blue. All right, so here again, now this is x equals 3. So, and this is just a number, a y. So when x equals 3, y equals -4. That's just telling me a point. Right? That's an ordered pair, 3, -4. Because that's equal to, it is a closed point. So 3, -4. And that's all there is for that part. And for the last piece, I will do in red here. Again, we take our condition, plug it in. 2 times 3 is 6. So we have the point 3, 6. Again, it will be an open circle because it's just greater than. Right? Pick a value greater than 3. 4, plug 4 in there. We will get 4, 8. 2 points again, enough for a line. So go ahead and draw our line here, and voila. All right, that is it for number 4. Then move on to number 5 here. All right, it says, given this graph of f of x, all right, graph each of the following: f of -x, f of 1/2 of x, and y equals f of x plus 3 minus 4. All right, so I'll do the first one here in red. My f of -x is simply a reflection across the y-axis. All right, so basically I am negating every x coordinate. So this point here, -3, 2, will become 3, 2. Right, this point here, that is 1, -2, becomes -1, -2. This point here, 2, 1, becomes -2, 1. And this point here, 4, 1, becomes -4, 1. All right, so we can still go ahead and connect our dots here. And there's our reflection about the y-axis. All right, the next one here I will do in blue. All right, this is f of 1/2 x. That 1/2 is on the inside. That means we are doing a horizontal, and this is going to be a horizontal stretch. Remember, when things are on the inside, it's kind of the opposite of what we think. So we're actually going to take all of our x coordinates and divide them by 1/2, which is the same as multiplying them by 2. Right? So instead of -3, 2, we're going to have -6, 2. Instead of having 1 -2, we are going to have 2 -2. Instead of having 2, 1, we're going to have 4, 1, which happens to overlap here. And instead of 4, 1, we're going to have 8, 1. So from here to here. From here to here. Right, so there's our horizontal stretch. Now I know it's starting to look a little messy on here because we have all of these graphs on the same grid. On your test, I give you a separate grid for every transformation that I ask you to graph. So, all right, and here y equals f of x plus 3 all minus 4. That is shifting it to the left 3 and down 4. So I take all of my original points. So here's one of them. I go left 3, 1, 2, 3, down 4, 1, 2, 3, 4. Put that there. I go to my second point here. I go left 3, down 4. So 1, 2, 3. 1, 2, 3, 4. I do the same thing with this point here. Left 1, 2, 3. Down 1, 2, 3, 4. And my final point here, I go left 1, 2, 3. Down 1, 2, 3, 4. So there is, I'll just go ahead and try to freehand this one. Right, so there's my original function, moved left 3, down 4. All right. Number 6, write the equation of the function whose graph is the graph of y equals the absolute value of x, but is a shifted right 2 and down 7. All right. So each one of these is completely different and separate. Don't think that you have to keep building on them. Some students try to do that on the test for some reason. You absolutely do not. All right, so here, if we move it to the right 2, that means I need to have an x minus 2 inside the function, which in this case is inside my absolute value. And then down 7 has a minus 7 on the outside. Right, B says reflected about the y-axis. All right, well, that's fine. All I have to do is put a negative on the inside. And C, vertically stretched by a factor of 3. So that's y equals 3 times the absolute value of x. Remember, vertical stretch is outside, and it's intuitive. It's what you would think it should be. So we're good there. Right, moving on to number 7. Find functions f and g so that f of g, which equals h, if h of x is equal to x squared minus 5x plus 6 all to the 7th power. Right? A lot of students get kind of confused on this one. It's actually much easier than what most students make it. Right? Remember with compositions, f of g of x or g of f of x or whatever, you always have an inside and an outside. Okay, so we're going to have an f of x and we're going to have a g of x. Right, remember for f of g of x is always the inside. Well, what is inside of this function? It's x squared minus 5x plus 6. That's my inside. Okay, now what's the outside? The outside, all you have to do is cover up your inside and pretend that it's just a regular x, and then you use what's left. So my outside is simply x to the 7th power. Right? So now if you think about what we actually do for a composition, if we will try to find f of g of x from this stuff going backwards, all I would do is take my g of x, plug it in for x here, and I would get exactly what's up here. So that's how you can kind of check yourself. All right, 8. Sketch the graph of each function. You must include at least 3 points. All right, so here we're just going to talk about what the transformations are. I believe on the test, all I do is ask you what the transformations are. Right? I don't actually make you graph them. The only thing that I have you graph transformations are like the one that we did up here on number 5, right, where I give you some generic graph and you have to transform those. Right? So with these, we'll just talk about what the actual transformations are. Right? Well, here, this plus 4 on the inside is going to shift it to the left 4. All right, next, we would come out here and apply this negative, which is going to reflect it about the x-axis. Right, and do be mindful that when you do reflections, you do have to tell me which axis you're reflecting it about. Right, it is, there's a very big difference there. And then finally, my last transformation here is going to be from this minus 1 on the outside. So that is going to be down 1. All right. Do remember that to get the transformations in the proper order, all you have to do is kind of think, what would I do if I were plugging in a number for this x? What uh, operations would I do first? So you basically just follow order of operations. All right, here we have the graph y equals the greatest integer of 1/3 x. Right, the greatest integer function is also called the step function because the graph of it looks like a set of stairs. I'll explain this a little bit more in detail in class one day, but for this exercise, you don't really need to know. We just need to know that there's a 1/3 on the inside, right? So that is going to be a horizontal. And because this is actually between 0 and 1, it's going to be a stretch. Remember, it's on the inside, so it's kind of the opposite of what you think. And you stretch it by the reciprocal of this. So this would just be a horizontal stretch. I guess I should say by 3, or of 3. All right, here we just have x squared minus 3. That's just my quadratic. And of course, it's just being moved down 3. And finally here, y equals the square root of x minus 5. That's just my square root function, and the minus 5 is inside, so that means I am shifting this to the right 5 units. And that's it for that page. All right, now we will go to the calculator portion. Although, just FYI, I'm kind of notorious for putting problems on the calculator section in which you do not need a calculator at all. All right, so just because it's on the calculator section, it just means that you're allowed to use a calculator. It certainly does not mean that you will need a calculator, or in some cases, that it will even really help you. All right, so here I'm finding the difference quotient. I have f of x plus h minus f of x all over h, and it gives me that my f of x is equal to 3x squared plus 5x minus 4. So I'll do that up here. All right, now first I'm going to do my f of x plus h, which just means anywhere there is an x, I'm going to replace it with x plus h. So I will have 3 times x plus h, and that x plus h will be squared, right, plus 5 times x plus h, right, and then minus 4. So that's my f of x plus h. Then, of course, I just subtract out my entire f of x. So minus, I want to put this in parentheses, so 3x squared plus 5x minus 4. And we want to put that in parentheses so that we remember to subtract out the whole function, which means to distribute that negative throughout. Do be mindful that x plus h squared is not just x squared plus h squared. I repeat, it is not that. So many students try to tell me that it is every semester. All right, remember, x plus h squared is really x plus h times x plus h. So when you multiply that, you get x squared plus 2xh plus h squared. So then when you distribute that 3 afterwards, we will end up with 3x squared plus 6xh plus 3h squared. I can distribute this 5, so plus 5x plus 5h, and then I still have my minus 4. I distribute my negative here. I'm going to get minus 3x squared minus 5x plus 4. And of course, this is all still over h. All right, well, if we did that correctly, right, lots of nice things should happen. This positive 3x squared, negative 3x squared, plus 5x minus 5x, and minus 4 plus 4 all cancel. So now I am just left with 6xh plus 3h squared plus 5h all over h. All right, well now here, everything in the numerator has an h, so I'm allowed to factor an h out, and that leaves me with 6x plus 3h plus 5, and that's all still over h, but now these h's cancel nicely, and we're simply just left with 6x plus 3h plus 5. And that is the final answer for the difference quotient. All right, number 10 gives me two functions, f of x and g of x, and it says to do all of our arithmetic on them, and all of our arithmetic operations. So add, subtract, multiply, and divide. All right, so first we will add. So f of x plus g of x. All right, so we simply have x squared plus 3x minus 7 plus 2x minus 7. We simply combine all of our like terms here. We're going to get x squared plus 5x minus 14. All right, for subtraction, we do the same thing. All right, except now when we subtract, we need to be careful to put a parentheses around our g of x so that we remember to distribute that negative to the whole thing. So we're going to get x squared plus 3x minus 7. And if I just go ahead and distribute the negative to this, I'll get minus 2x plus 7. All right, so now again, at this point, it's just simple combining like terms. So we will get x squared plus x, and my minus 7 and plus 7 cancel, so that would be my answer there. All right, next we will look at f of x times g of x. So just straightforward multiplication. So x squared plus 3x minus 7 times 2x minus 7. I'm going to go ahead and distribute all of these. You can use your box method. You can use whatever you like. But we're going to get 2x cubed minus 7x squared plus 6x squared minus 21x minus 14x plus 49. So then, of course, when I go ahead and combine my like terms, I will get 2x cubed minus 1x squared minus 35x plus 49. All right, get there, and then last but not least, division. All right, so f of x divided by g of x. All right, so this will just equal x squared plus 3x minus 7 over 2x minus 7. Remember, you can only simplify these, right, if you can factor the top, factor the bottom, all right, and something cancels. You can't just randomly start canceling things just because you think that it looks like you should be able to. Right? That's definitely not how it works. All right, this is it. We can't do anything here, so we're done. All right, number 11, we're going to do some composition, f of g of x and g of f of x. All right, so f of g of x, we take our g function and we plug it in everywhere where there's an x. So there's more than one x here, so we're going to be plugging it in more than one spot. So when I do that, here I have an x. So instead of x, I replace it with 7x minus 2, and that's going to be squared because this x was squared, minus 4 times x, but instead of x, I'm replacing that with 7x minus 2, and then I have my plus 1. All right, here again, of course, remember that you're not just squaring each piece in here. You actually have to do 7x minus 2 times 7x minus 2. And when you do that, you will get 49x. Then you would get minus 14x minus 14x would be minus 28x. And then you would get plus 4. And then here we will have minus 28x plus 8. And then still have our plus 1. So now we simply combine like terms and write it in standard form. And of course, sorry, that should be 49x squared here. So we're going to have 49x squared minus 28x is minus 56x. And then 4 plus 8 is 12, plus 1 is 13, plus 13. All right. Now here we go the other direction. We have g of f of x. So I actually take my f of x and I plug it in for x here in g. So when I do that, I will get 7, but instead of x, I'm replacing it with x squared minus 4x plus 1. And then I still have my minus 2. So I just go ahead and distribute. We get 7x squared minus 28x plus 7, and then I have my minus 2. My only like terms here are at the end, so this will be 7x squared minus 28x plus 5. And we are done there. All right, number 12. Find the inverse of this set of points. It gives us the points 2, 3, negative 1, 5, 3, 7, and negative 5, 3. Is the inverse a function? Explain. All right. So when you're trying to find the inverse of a set of points, it's really easy. Okay. So my f inverse here, all I have to do is switch all of my points, all of my x's and y's. That's what an inverse function really does. So instead of 2, 3, I will have 3, 2. Instead of negative 1, 5, I will have 5, negative 1. Instead of 3, 7, I will have 7, 3. And instead of negative 5, 3, we will have 3, negative 5. So there's my inverse. And then it asks, is this inverse a function? Explain. Okay. Here I would say no, because one of my x's, 3, goes to 2 different y's. So you say no. An element in the domain, and then I'll just put 3 in parentheses since that's the element that I'm talking about, goes to 2 different elements in the range. And we are done. All right, so now we go to 13. All right, it says graph f of x equal to 1/2 x plus 3. So I'll go ahead and graph that first. I will do it in blue. All right, this is just a linear function. All right, I've got a y-intercept of 3 and a slope of 1/2. So up 1 over 2, up 1 over 2. I can do that as many times as I want, or down 1 to the left 2. All right, so go ahead and draw my line here. All right, then it says to find the inverse of f of x. All right, so now I'm going to find the inverse. Remember, I make this a y, and then I switch my x's and y's. So this becomes x is equal to 1/2 y plus 3. Well, now I go ahead and solve for y. So first I'm going to subtract 3 from both sides. And then to get y by itself here, I'm going to multiply everything by 2. So I have to multiply this by 2 and this whole thing by 2. So these will cancel. I end up with y is equal to 2x minus 6. It also then wants me to graph that. So I will graph this in red. So now I have a y-intercept of -6. So 1, 2, 3, 4, 5, 6. And I have a slope of 2. So up 2 over 1, up 2 over 1, so on and so forth. And I can use those points to draw my line. So there are the graphs of my inverses. Then it asks to discuss any symmetry between the graph of the function and its inverse. It doesn't matter what the functions are. No matter what, you can always say f of x and f inverse of x are symmetric about the line y equals x. Inverses are always symmetric about the line y equals x. And the last problem on the review, verify that f of x is equal to f of x equal to 2x minus 5 and g of x equal to x plus 5 over 2 are inverse functions using compositions. It says using compositions. It will say that on the test as well. You must use compositions to get credit for the work. So composition is f of g of x. You could also do g of f of x. Either way, it's going to come out to the same thing. So if I do f of g of x, I take g of x and I plug it in for x. So when I do that, I will get 2. Instead of x, I replace that with x plus 5 over 2, and then we have minus 5. Well, here, this x plus 5 is being divided by 2 and multiplied by 2, so these just cancel. So then we're left with x plus 5 minus 5. Well, plus 5 minus 5 also cancel, just leaving me with x. And that's what I want. If we do the composition either way and we just get x, then that shows that f and g are inverses. So since that, we can say g of x is equal to f inverse of x. And we are done. If you have any questions or concerns, please go ahead and shoot me an email or anything. Those of you that are BDA, I'll see you tomorrow in class, and you can ask me there. Have a good day.